Now what we're doing is we're combining our subtraction, addition, multiplication, and division of positive and negative integers all into one problem. So there are a couple things that we want to go over just to make sure that you can figure out how to do PEMDAS in its correct order. So PEMDAS is really what we're trying to do in terms of orders of operation. The P in PEMDAS is parentheses, but I'd like us to really think of it just as grouping in general. So whether the grouping is done by our parentheses like this, or if our grouping is done by, let's say, a fraction line, I would like both of these things to be the same thing, which they are because the two ways that we're grouping here achieve the same thing. 4 plus 3 needs to be done first. If 4 plus 3 is on top of a fraction line, then that is what's grouped first. Before you divide by 2, you need to add these together. And before you divide by 2 here, you need to add these together. It means the exact same thing. So for instance, if we had something that looked like 5 plus 9 over 2, that would be 14 over 2, which would equal 7, okay? How about the E in PEMDAS, which is exponents? Exponents look like little tiny numbers at the top of the right-hand corner of this larger number, which we call the base. So here the base is 3, the exponent is 2. This exponent is telling us how many times the base needs to be multiplied against the base itself. In this case, it's 3 times 3 because there's 2 for the exponent. If there was a 3 as the exponent, it would be 3 times 3 times 3. If there was a 4 as the exponent, it would be 3 times 3 times 3 times 3. Okay, so this would equal 9, this would equal 27, and this would equal 81. 3 times 3 is 9, times 3 is 27, and 3 times 3 is 9. This is 3 times 3, which is 9, and 9 times 9 is 81. So that works for any exponents that we have. Let's say that we had a negative exponent, a negative base. So let's say we had negative 2 to the third, okay? Again, everything in here, this parentheses, is going to be designated as that base. So that means that we want to multiply everything in here against itself however many times this exponent tells us to, which in this case is 3 times. So it's negative 2 times negative 2 times negative 2. So you do negative 2 times negative 2. 2 negatives, when you're being multiplied, will give us a positive. So that's positive 4. And then you multiply that times negative 2. Negative 2 times 4 is negative 8. So it turns out that negative 2 cubed is going to be negative 8, as long as the negative 2 is all in that parentheses. If we had, let's say, we had negative 4 squared. So everything in here is part of that base. So that'd be negative 4 times itself, because we want to multiply negative 4 against itself 2 times, just as the exponent tells us to. Negative 4 times negative 4, negative times a negative will make a positive, and 4 times 4 is 16. So negative 4 squared is equal to 16. So now we can add these kind of exponents into our PEMDAS in grouping of things. Now, how about, let's put it together. So let's say that we have negative 4 squared plus negative, say, 4 all over 2. So how would we do that? Well, we want to do first our grouping, and we'd love to do our grouping here, but in order to do our grouping here, do you see that we have a plus sign? So that's where it's really important for us to understand this concept in the context of PEMDAS. We'd love to do this grouping first because this fraction line is a way of grouping, but within that grouping, we still need to add these two terms together because this term has not been simplified yet. We need to do the exponent here. So here, remember, -4 times -4 is a positive 16. So this right here is like positive 16. Positive 6. Now we can do what we ultimately wanted to do in the first place, which was grouping. And now, since we are just left with numbers with no exponents, we can do the grouping. So 16 plus -4 is positive 12. So this becomes positive 12 up here. And now it's 12 divided by 2, which is going to be 6. Okay, so I'll give you a chance to use what we have learned in this video to simplify some more complex problems.